I'm going to talk about monitoring with and monitoring Puppet, because I think they're both, well, if you're monitoring something, a good example is to actually monitor your Puppet infrastructure. For those who don't know me, I'm Kris Buytaert. I have a large background in doing open source consulting for the past 15 to 20 years. I'm currently, my role is the chief travel, trolling, whatever officer at NETWAYS, which is one of the larger European open source consulting companies. Some of my colleagues was asking when they will conquer the German market, because we now have offices in the Netherlands, in Belgium, and in Czechia, so we could capture you guys from both sides, but that's not really a plan. So you might know me from organizing way too many conferences. I think Bernd does more than me, but he has a team for that. But I'm involved in DevOps days, in Linux Open Administration days, and a bunch of other conferences around Europe. So you might have met me there before. And if I look at what I've been doing mostly since I started organizing DevOps days 5 years ago together with Patrick, it's actually helping organizations to deploy software better, faster, stronger. And we call that evangelizing DevOps. So, do you know what your children are doing at 5 a.m. in the morning? And those who don't have children, wives, family, whatever. Yeah? Are you sure? Depending on how old they are, they're probably sleeping. But if they're a bit older, you don't know. You're not monitoring them, because we kind of try to trust them. The problem is that, well, you cannot trust machines as good as humans. Sounds weird, right? Because machines are instructed to do stuff by humans, and humans make mistakes. So, if I'm giving a talk, I always like to position why we're talking about monitoring and why it's important for DevOps. And DevOps, for me and for a lot of people, can be summarized best by using the CLAMS keyword. It's about culture, it's about automating all the things, build automation, test automation, infrastructure as code. This is Puppet Camp, so you guys should know what infrastructure as code is by now. It's about monitoring and metrics and about sharing those experiences. And the M is really a big and important part. But usually when people start doing an infrastructure project or an application project, they don't think about monitoring. They just figure out that the first time a site goes down, why didn't we know? Why did our customer call? Why is our CEO calling us that the application doesn't work? Because usually it's not booked in a planning, there's no time for it, there's no budget. And another reason why it's sometimes not in there is because a lot of people think they think monitoring sucks. Who thinks monitoring sucks here? Oh, God, this lunch must have been really good because you're all asleep. So, back, I think about 2.5 years ago, John Vincent, Lucy's on Twitter, started tweeting about his hate on the current state of monitoring tools back then. And it was really frustration, anger, and the hashtag monitoring sucks actually became a trending topic. And for me, since then, it became a sub-movement of the DevOps movement. Stuff that happened was people set up a GitHub repository with pointers to all tools that they knew which were in the monitoring area and tried to get a grip on what was actually usable and what was not. And what happened there was people started organizing monitoring hack sessions, people started organizing monitoring conferences, Monitorama happened, and people started loving monitoring again. At DevOps Days Rome in 2011, Ulf Manson gave an Ignite talk with pictures drawn by his kids, that's why they're so nice, about how he found a tool which really got him back into monitoring, which really made him love his job again. He had a pretty specific setup where he had a pretty flexible environment, machines disappearing, reappearing, and for him, Sensu was a tool that really made him happy about monitoring again. So let's talk a bit about infrastructure as code and what, for a lot of companies, still is a major problem. We've been trying to talk and work together with developers and make sure that they were testing their code. We had a reproducible way of deploying their code, and we could actually help them in getting software deployed faster. But at the same time, those same people were just logging on as root to a machine and hacking stuff around. And we didn't know why people were forcing quality onto developers, but just letting root people change things manually. So who let this happen? Why did this happen? Infrastructure as code, led by CF Engine and then Puppet took over, is really helping us to solve this problem, really helping us to make sure that we can now also, as systems people, build stable infrastructures. And it means that we start modeling our infrastructure, that we pretty much make sure that the blue part here, operating system, middleware, databases, application stuff, that's all written down in code, and if we deploy a platform, it's going to be all over the same, upgradable, maintainable. We're going to then give an identity to a platform. This is acceptance, this is production, this is test, and some actual user data. And if we do it this way, we can build from scratch, restore a data center with little overhead, and just only need to take care about the customer data. But we say infrastructure as code. So what do we mean? We mean that we also need to start thinking like developers. Like Luke just said this morning, we're all developers now. Martin said that this morning. We're all developers now. Code is code. Puppet manifests are code. So we need to think about version control. We need to think about quality checks. We need to think about testing, continuous integration, and actually think about doing continuous delivery of our infrastructure. So developers write checks and tests. We should do too. And those tests we can also reuse for monitoring. So if we do this, we build a core infrastructure, we build middleware deployment, we build everything automated, and we also get monitoring involved, both on host, service level, and application level. So who's doing that today? I see a couple of hands. Why not? Well, the reason why lots of people don't do it is because they're stuck with broken tools. They have to configure their monitoring tool from a GUI, point and click. Usually monitoring tools are not in sync with reality anymore. When you deploy 5 new machines, people forget to add that config to their monitoring tools. A lot of those people focus on monitoring basic services and just the hosts. And they forget about actually monitoring the business functionality inside the application. So what happens, they deploy a Linux server with Nginx, with MySQL, and they test if that works. And the Nginx is there, happily sitting, returning OK when you get a page. But the page is full of errors. The application does not return the right code. So the monitoring isn't relevant. And what happens after a couple of iterations, after a couple of months, a couple of years, the monitoring setup is completely out of sync with what reality is in the platform. So some of those tools that have figured out that that is a problem move to auto-detection. They move to try to figure out which nodes are on the network and try to figure out which services were running on there. So they can ping nodes, they can see if there's SSH running, they can see if there's HTTP running, they can see if there's... But what they don't know is the actual business functionality you pinned in there. So if there's an Apache running on port 80 and on 443, what they don't know is the number of vhosts that should be there. They don't know which application is actually supposed to be there. However, you do know, because you're using infrastructure as code, and you know what you just wrote in a Puppet manifest that configures that server to have that application running. So why shouldn't we use that? So if we look at a basic monitoring setup, what we do first is we deploy a host, we add it to the monitoring tools, we add some metrics collection tools if we need them, we add check definitions, we update the monitoring tool, and we restart it over and over again. I mean, isn't that something a machine should be doing for us? So let's talk a bit about getting metrics. when we deploy infrastructures, in our baseline, we always do basic operating system metric detection and basic application metric detection. We use a tool called CollectD for that, which comes with a zillion plugins. It knows about Nginx, it knows about Apache, it knows about MySQL. And what we do there is we flush all those metrics to Graphite using the Carbon plugin. Obviously, that stuff is completely puppetized. The slides will be up later, so you don't need to write stuff down. But there's Puppet modules that allow you to configure a whole CollectD setup by just including the module. For every single module that I'm going to mention, please send pull requests if you fix stuff. We try to get stuff as good as possible, but time is only finite. So we send those metrics from CollectD, usually to Graphite, which means we also have a fully puppetized Graphite setup, which includes a bunch of tools. And there's a Vagrant box, which last time I checked, it still worked, but that has been a while. But it's as simple as pull in a Vagrant box, do Vagrant up, and you can actually use that same code to build in your infrastructure. So now you have CollectD, which sends metrics to Graphite. And, well, you need to visualize those metrics. So the next thing you need to do is find out which of the 25 different Graphite dashboards is going to be the good one. Because nobody actually uses the relevant, the default Graphite stuff. We used to do a lot of stuff with GDash, but we're slowly moving currently to Grafana. So that's what people do in 2014. So what you see there is that even now we have a really modular system where there's metrics collection, metrics storage, and metrics visualization. Those tools are actually interchangeable. So we can really just replace Puppet modules, and if we figure out that for some setup, Graphite with Carbon as a backend doesn't scale enough, we can probably replace that with Influx in a couple of minutes, not taking into account the data migration and all that stuff. So that brings us to, we've got some collection, we've got graphs. We're now doing every single machine we deploy. Default, we get a new entry in Graphite, and we get all the metrics which we can correlate on a dashboard where the developers, if they want to add metrics to their application, automatically also get those metrics. So what's the next important part in monitoring we need to fix? What? Alerts. You want to come up here and give this? No. Usually that. Monitoring sucks. Socks or no? If you go to Monitorama, you get socks. So, one of the things I said when we do DevOps, it's monitor all the things, measure all the things, automate all the things, so we also alert on all the things, right? No, because then we get alert fatigue. And depending on where you live, the tool chain you use is going to be different. And I specifically write here that we are in Germany, Europe. And to me, the specific part is Europe, which means that most organizations still have pretty static workloads. Is there anybody here deploying on Amazon? I see one hand and one half hand. If you do the same question in the States, there's a whole room going up. And to me, that means there's a difference in toolset we need. The second thing is we're in Germany, so I think even pronouncing the word nagios is illegal. So there's a limited set of tools which you can actually use. Back in 2007, I guess, we did a study which we presented at Ottawa Linux Symposium, which was trying to compare all the open source monitoring tools that were out there. And we started from a really huge list, came down to like eventually 4 alternative tools, which back then were Hyperic, Xenos, Zabbix. And then we had another discussion, which was which variant of, well, Nagios. So we chose Ichinga. And out of those 4, we started figuring out now which one do we really like. So one of them was a bloated Java solution which we didn't want to deploy on top of other services because the footprint for the memory solution, for the monitoring solution was bigger than the application itself usually. The other one needed a full-time MySQL database engineer if you grew up to a setup for more than 400 nodes. And then there was the other one, which was, okay, you could do this. It was a really nice interface, point and click. But the developers were not that easy to talk to. I think it was partly a language barrier. And they were really building a monolithic thing, which was not really easy to configure. I was actually helping out with writing a review of the Zabbix book during that period. And even during writing that book, the API, to try to configure stuff, changed it a couple of times. So we actually, the last chapter, just skipped that because we realized that by the time the book was going to be published, it was not going to be the same anymore. So with that in mind, we really came to the conclusion that there was pretty much only one real tool that still could help us forward if we wanted to do Puppet, if we wanted to do infrastructure as code, and reconfigure and build our infrastructure and our monitoring setup the same way we wanted to do with all the other applications. And that was for us, back then, the early days, Nagios, but that slowly and fastly evolved to being Ichinga only. If, however, you do live on the public clouds, if you do have environments where you have 5 nodes now and 50 in 2 hours, and then 300 in a couple of days later, and then back to 25, 3 hours after that, there's different tools. But given the fact where we are now, my favorite setup is still Ichinga, and if we need to do private or public cloud setup, I'm going to mix that in with probably with Sensu. But keep in mind, if you do stuff with Sensu, you get queuing involved, you get RabbitMQ involved if you want to cluster RabbitMQ. I was walking in Stockholm in January with that same old man who had his refound love, but now he's actually fighting with queues because of scale and size. So every of those solutions has its benefits and its negative points. So who here likes writing an Ichinga config? Who here works at NETWAYS? You don't like writing an Ichinga config? You need to talk to your developers and fix this. You don't write any config. I don't write it either, because I can have it generated by a machine. Some people tell me that that part of the config is actually data, and that you shouldn't have Puppet create data. And we often have the discussion about if you're, for example, deploying a database, how far should you go? Should you do the table creation? Should you do the user creation? Should you just do the schema creation? And in a lot of discussions, we end up going to the point where you do the schema creation and the user creation, but everything else is the responsibility of the application. Now, if you map that to the monitoring setup, it's different, because an application, people define what's going to be inside their database, and it's not something which is going to be generated. It's not something which is going to be changing over the time based on your environment, based on the state of your environment. But for a monitoring configuration, you know what you want to monitor. You can determine that out of the systems you have just defined on how they need to deploy. So it's really the best way that a computer does that generation for you. So why not let Puppet actually generate the configuration for your monitoring system? So I'm kind of assuming you all know Puppet. And actually up till 2 months ago, I was kind of also assuming that if you knew Puppet, you knew stored configs. Who knows stored configs? Okay, that's already better than the last time I asked that question. Still, I'm going to need to explain for the others. And the credit for this picture goes to Brice Figueroa, Masters on Twitter, because he used it in his first presentation about stored configs, and I've been using it since, because I don't like to redraw stuff. But basically what happens is when a node has a resource which it wants to export, your Puppet run throws that up to the master, export that resource, stores it in, well, it used to store it in a MySQL database, but it's 2014, so now we store it in PuppetDB. And then there's other nodes which can go to the puppetmaster, go to PuppetDB and say, now, give me all of the exported information. In code that looks like this, on one side you export the resource, and on the other side you collect the resources. So what happens here? I have a web server, and I export my Apache vhost, and on the other side I collect it. And I can now also know that I need to monitor this. If you have nodes that disappear, don't forget to clean them up, because otherwise you keep having a monitoring setup which is alerting on a node that has disappeared. In actual Puppet code, and this is actually a part of the Ichinga Puppet module, if it's a server, if it's an Ichinga server, you are going to connect all of the Nagios hosts, all of the Nagios services, and you're going to, if it's needed, restart the service. And if it's a client, you're going to export all the hosts with all the parameters, and you're going to also define the checks. So with this in place, every single node which pops up does its first Puppet run, registers itself to the PuppetDB, and then the next time Ichinga does its own Puppet run, it's going to collect all of these and reconfigure itself without you doing anything. Now, Puppet has helped us by giving us a large number of default resources with Nagios in there. Do you know if that's going to... I heard something about this being removed from Puppet Core and being moved to a module, but I'm not sure. I heard something in the back. Was that you, David, or...? So they wanted to do that. I know that there was discussion about that at the Contributor Summit at PuppetConf 3 weeks ago, but I haven't followed up on the end result. Anyhow, even if it does move to a module, these things are still going to be around so you can use them. And that's already a large part of the things you want to be able to configure. They're in Puppet by default, or in a contributed module soon to be by default. And then obviously what you also want is the Puppet module I just showed, which is on our GitHub repository, Puppet Ichinga. And we do accept patches, and we are working together with Michael to get a version 2 out there. So what if we want to monitor an Apache vhost? We do something like this. We define an exported resource, which is a service, which does a check HTTP. We get all the parameters from the host. We have the fully qualified domain name in there. These are parameters which we set or we can overwrite in the Puppet module, and we write it to a target configuration file. And that's pretty much how it happens for any single service you want to do. But this obviously would be too easy. How many of you have setups with more than 500 nodes? Okay, more than 1,000 nodes? So for the two of you in the back, there's alternative approaches when you reach scalability issues on having the Nagios configs being rewritten in a Puppet run and using that with exported resources. There's James Fryman from GitHub who has an external tool which he uses to query PuppetDB and to create a config file from that. And pretty much the guys from eBay in Amsterdam have a similar tool, because they ran into a setup where it took them way too long to query all the data out of PuppetDB using Puppet and then generate it. So they put another tool in there, but they still use the exported resources. So what do we have now? We can deploy a new application. In the profile where we define how the application is written, is deployed, we add monitoring. We add real application monitoring. We do health checks on the application. And we get metrics and alerting if we deploy a new physical or virtual machine with all the data in there automatically. So let's see how that works for monitoring Puppet. What's the first thing you want to monitor when you're running a Puppet infrastructure? Master. Yes, except if you are running masterless. No. Indeed, what you do want to monitor is master, but what I'm more interested in is Puppet runs. And there's different ways to do that. The upper screenshot is from an ancient Puppet dashboard, which people are still using, where you get a clear view of the trend on how your Puppet runs have been running. This is a small setup, but there's a constant 2 nodes failing. Does anybody know which 2 nodes are failing? Those are the 2 Windows nodes. I'm not kidding, by the way. The other setup here, that's 3 hosts. Those are not Windows hosts. Those are the actual nodes on the development platform on the Vagrant boxes that are failing. But with Foreman, you also can get a much view on what's going on and what the Puppet runs is. But indeed, the second most important thing you want to monitor is actually the puppetmaster. And the monitoring plugins community wouldn't be as big as it was if nobody had not written a check puppetmaster yet. So on GitHub, real names mapping to IRC names and Twitter accounts. Some Dutch guy living in Australia. That's probably close enough. Wrote a monitoring plugin, which is called Check Puppetmaster, which has a bunch of nice features, which we use. And the other basic thing you want to do is check these, because this module pretty much goes check on the Puppetmaster, if the agents have checked in frequently, if they're not running stale, and they pretty much get the same functionality as this, but on the Puppetmaster in an adjust check. That's one way. But what I also want to do is make sure that my Puppetmaster is still running. And the most trivial setup is to actually check a TCP port or do an HTTP connection. And as this is an adjust written in Puppet code, it's an adjust service which checks port 8440 on this node, and we get alerts if we want to. So what's another critical component in your Puppet infrastructure? What happens when PuppetDB is down? Okay, let me rephrase the question. Who's running PuppetDB? What happens when it's down? Well, your Puppet runs don't work. They're going to fail. But your store configs won't work. Your exported resources won't work. Puppet is pretty much going to die when PuppetDB is down and the Puppetmaster cannot connect to PuppetDB. So guess what? Somebody wrote a monitoring check plugin for that. Jason Hancock wrote a nice number of plugins which, because the PuppetDB is running on a JVM, are pretty Java-centric, but he's doing a lot of stuff. He's, like with any Java setup, the first thing you do is you monitor its memory usage. But then you also want to know how many Puppet reports have been processed, how much resources, nodes, and how much resources per node you have in your database, so you can see how your infrastructure evolves. And, well, you also want to know if the reports are being processed, if your database isn't down. So that's why you also need to check the queue. And if the database isn't down, well, it could also be that ActiveMQ is breaking up internally and you need to clear up the message queues there. But that's a whole different story. I should have done that one in my 7th story. That would have been the 8th horror story. Debugging ActiveMQ on Puppet. So with this checkup in place, we now have really good health metrics on how PuppetDB is running and if we should take actions. Any other components you want to monitor? I want to monitor the dashboard. And pretty much monitoring the dashboard is similar to monitoring PuppetMaster. If I can still connect to port 3000, I'm pretty happy. You can go further. You can actually monitor the queue there for Puppet Dashboard also. You can monitor the number of files in this directory. And, well, usually Itchinga comes telling me that my disk is about to flood because of this directory on a Puppet Dashboard server. And that means usually that I need to get more workers going or that I need to clean up the queue and clean that up. And now I'm thinking I'm going to see, oh yeah. Remember monitoring sucks? We've got it all automated, yet still, Puppet runs started breaking our Kinga boxes, frequently, badly. We had some issues with disk usage, which was growing like hell. And we saw successful Puppet runs. Anybody who did not see my PuppetConf talk has an idea what this is about? Yes? Something file bucket. Yes, exactly. Because Puppet actually takes backups of files if they are being modified. And there was a small bug in Puppet with when you had an empty parent definition in your host, didn't clean up the file buckets. So if you do a lot of config file generation on Nagios, you really need to make sure that you have defined, if you are using parents in that setup, you have defined a parent. Because otherwise, your disk will flood. It's easy to clean up, but it might be non-trivial to find. So, what was the first thing I started talking about? It was about collecting metrics and graphing them. And now we were talking about alerting. So I'm collecting a bunch of metrics where there's nice graphs where I could actually do stuff like alert if, for example, the certain number of files in this directory, in the queue directory, stays there for a longer period. But that's not really trivial to do in standard monitoring solutions. So what we do there is, and I've got this example as Java thing. If, for example, in the JVM, the memory usage stays too long over a certain period, what we do is we collect the metrics, we use JMX trans to ship those to Graphite. And it's pretty much exactly the same setup. You export resources, you collect them on the other side. So the JMX configs, export it on the node where the Java application is running. You import them on the node where JMX trans is running. And then we have one check, which is the queue length. Is this the one? No, this is the one. We have one check, which is check Graphite. So we have the graph exported. We check on Graphite, using the Graphite API, that we want the messages over a period of 30 minutes. We want to have a warning if they stay over 2,000, and if there's more than 20,000, over the period of half an hour, we send a warning, an alert. So this is how you can actually measure based on graphs. Same here is the config is you export. This is the graphite check. The graphite check is exported on the node where you run the actual application because you want to tie the alert to the node and not to the graphite server. This is the part where we export the Nagios check. The example here is Hornet queue, which is one of the queuing servers which you can use in the Java world. These are the metrics we export: message count, message added per time frame, and the message consumed. And then pretty much export this, collect the metrics I want to collect, and this is the actual check. So what we have now is a setup where we can alert both on metrics and on actual failing services. We can do that automatically. And what there is for me to conclude is that if you are doing Ichinga setups, make sure that you have your parents filled in. Otherwise, you will have problems. Stop writing Ichinga code manually. Also, don't put them in Git repositories. Don't package them. Have code generate your configs. And really do monitor your Puppet infrastructure also, because they do fail, even if it's because of flooding disks, even if it's because of passenger and stuff that fails. And well, even though we are moving to the JVM, Java apps fail too. And yeah, if you work on one of the modules that I just talked about, feel free to send pull requests. If I don't fall asleep or am I traveling, then I usually merge them pretty quickly. That was pretty much what I wanted to tell you. Any questions?
Just to get it straight, I'm not very familiar with Nagios, but do the Puppet agent triggers Nagios to collect the data and put that back into the PuppetDB for a check, like the HTTP check?
No. So it's that would be a whole other approach. You could actually use mcollective to trigger checks and report them to Ichinga, but what we actually do is use the default Nagios setup and have that trigger checks remotely, or use NRP to do them on the machine locally. But that's, Puppet is not involved. Once the setup is there, you could, if you don't change the environment, just completely disable Puppet. So it's not, Puppet is not used as a transport mechanism to do the monitoring. But you could do tricks. I think Ari Pinar wrote a blog post on how he actually uses the monitoring plugin checks, but triggers them from mcollective. That's a completely other approach, but it could work too. It kind of is in the same philosophy as Sensu works.
Any other questions? Okay, thanks, Kris.
Thanks.
Oh, I missed one. Troublemaker.
How do you monitor logical errors in your Puppet configuration? So let's imagine someone broke node classification or whatever, and you're installing wrong software on your systems. Do you have a monitoring for that situation? Because that would mean that also the monitoring would change, and I would not realize that Puppet misconfigured my environment.
Wait, can you repeat the question again?
Sure. Just an example, let's say I'm deploying a lot of services with Puppet, and I made errors in Puppet, so I'm deploying wrong software or something. I'm deploying the wrong, and doing, let's say I do the node classification wrong, so I get installed the wrong software on the wrong nodes, and the software gets missing as Puppet changes my system, but this also means that monitoring changes, and they are going silently to go away from my monitoring, and I could not realize this.
Yeah. So I think I should respond to that with a famous DevOps Borat quote. To err is human, to fuck up automatically is DevOps. So yeah, we have those situations, but we have also, in most of our environments, we have development, acceptance, production. So when we go through a pipeline with our whole code and we see that we are removing services completely, there's going to be acceptance tests failing. And acceptance tests are still being triggered from outside of the monitoring solution. So we should catch them before that happens. But I've actually never had that happen that I recall of. But yeah, could happen. Any other
Okay,
questions?
thanks, Kris.